in the middle of the Atlantic Ocean, there is a packet that is stranded right now. And this, we never think about how data is traveling. We only think about going online and clicking enter and getting the data right there. But however, data is built up in different routers, cables, networks, switches. And if one goes out, then it'll cause multiple issues with the internet and the routing. Such as like gamers will rage quit, such as Wentao, and Wentao can't play his video games in class anymore. And these are a lot of big issues that we have. Or, this, now we can introduce this Tracerouter. And what Traceroute does is allows us to expose the hops, the delays, and the failures of internet. And this can allow us to figure out better ways, such as engineer when there's a traffic delay, to reroute these internet failure issues. So now let me introduce you our project, our Traceroute. Okay, so let me introduce to you this our design network and our architecture for this. So we have an input, and these input modules allows you to input this file that's a CSV or TXT, and this would do is it handles this file based on the data and what's uploaded, and they have these separate parameters such as the hops and the TTL, something broad. And then we have this input audio as well, because we have a very cool feature that allows you to text to speech, and this allows like an audio based input, and it's essential for your voice, where you can say google.com. And then we'll participate into this route of a handler when you do the input file and input audio. And this handler is, you can think of it as like a brain of the system. It coordinates to process the incoming data to be a text or audio and decides where it goes. So then this handler can go to the Traceroute, and then the Traceroute will send it back and go to the output like that. And then it can, before we get into this this Traceroute more idea, we can speak about the output, where the output is just processing and saves results into a file format and future references, while there's also a console log where it displays like real-time feedback, such as the system status and like the diagnosis messages. And there is this Traceroute where it runs this network path and it shows each hop between your device and the destination server, which we'll get more in depth to in the back end part. And then there is a map where it provides like a graphical geographical view of like all the traces worldwide that will be displayed in the output, where we get this big earth around. And then it works together. And so all these, like from the front end to the back end, where the back end starts is like the base of it, and it works together to produce an output, which we can see a model. Now quickly, to be in the front end is we have like these APIs where we use for the IP to be traced, and then where we will then display these nodes onto this map, and then we have like a polyline map crossing it, and that's part of our front end design here. But we will go more in depth in the details later about the features and such.
Okay, so now let me show you how to use this app. So the first thing is npm install to set up the environment for this, and then we use sudo npm start. Okay, so now you can see a separated page of an Electron software app. And obviously in the center of this page, there's a P5 canvas, which is implemented by the P5.js library. The blue sound wave here represents the volume of the input of the microphone. We use Bezier vertex to implement this sound wave, and the length of each lines over here are determined by the microphone input and the noise generated by a sine and cosine functions. And in the console log over here, we can see those data are the volumes, which are the microphone inputs. Okay, so now we can automatically perform the traceroute to this google.com. Okay, so now we can see a 3D globe over here, which represent the Earth, and then the points here are the routers. Okay, this is the starting point, which is our school, and the Traceroute performs several hops from our school all the way to the last hop, which is the destination. Okay. There are only a few points on this map, because some of the nodes are very close to each other, so they looks like the same node on this map. It doesn't matter, for example, like this.
Okay, now I will go to show the features of our projects. Let's talk about our brand new text-to-speech features. One of the key features of these Traceroute tools is the integrated text-to-speech functionalities. For example, you can simply say google.com and the system will automatically connect to the corresponding server. And this voice-activated approach streamlines user interaction, making it especially useful in multitasking environments or live demonstrations. Of course, traditional input methods are still supported, allowing you to type in a URL or IP address if you prefer. Once connected, you will see real-time hop and IP address visualization. Each hop displays its IP address and status, allowing you to observe how your request travels across the network from start to finish. To enhance this feedback, we have included both visual and auditory cues. A sound wave visualization accompanies each hop's response, ensuring you can track the process by both sight and sound. We also offer a 3D Earth map display that integrates latitude and longitude data with IP address to pinpoint the exact physical locations of your network nodes. As the traceroute progresses, markers appears on the globe, indicating each server's or hop's position. This geographic perspective is particularly valuable for large-scale or international deployments, or simply for gaining a clear understanding of how data moves around the world.
But now we move to the backend.
The backend is the backbone of this project, and it consists of two .py files: traceroute fix.py and handler.py. So first, let's focus on the handler. The handler acts as the entry point for the traceroute backend. It processes the front-end inputs, also the options, and forwards them to the traceroute.py. So its workflow is like this. So first of all, it opens the input file according to the file path, and then it reads each line from the file and passes it to traceroute. It also receives the results and saves it in the traceroute results folder as a JSON or TXT file named after the URL. After finish one iteration, it repeats the process until the end of the input file is reached. And now we can move to the traceroute. Here's how it works. It receives configuration options and the target URL from the handler, as we have mentioned. And then it initializes all the parameters and sockets. So the key feature of it is it's using a thread pool to create multiple receiver threads, and then it sends probes based on the specific options via the socket. After all of these things have done, it will continuously check if the return package indicates the destination has been reached. So if the destination is reached, it will stop all threads. Or if the maximum time expires after the last probe is sent, it will also stop all the threads. And finally, it will process the received data, prints the traceroute result in the console, and returns a structured dictionary.
Wipe it down. Wipe it down. Wipe.